number 8, some of you guys might be thinking, oh, this is a 3, 4, 5 Pythagorean triple, so x is the square root of 4. However, that's not the case because it doesn't work when the Pythagorean triple is underneath a radical. I need to do the regular Pythagorean theorem on this. If I do the regular Pythagorean theorem, I have an x squared plus a root 3 squared is equal to a root 5 squared. An x squared plus a root 3 squared is just a 3, and a root 5 squared is just a 5. Subtracting 3 from both sides, I get x squared is equal to 2, and taking the square root of both sides, 2 is already the simplest radical, or the square root of 2 is already simplified. That's the simplest radical form. So x is the square root of 2. So we do need to state here that the following triangle is not a Pythagorean triple. Because when we do the Pythagorean theorem, we do not get a multiple of a Pythagorean triple. And that's it. All right, moving on to the next page. So for the next page, we have an isosceles right triangle. So what that means is I'm going to draw myself a right triangle. I have this cool little tool to do it. You guys don't. You'll have to drop my hand. Triangle ABC with base AC, that means that this is AC and the right angle is B, and AB is congruent to BC because the hypotenuse needs to be the longest side. AB is 2 root 5, which would mean that BC is 2 root 5. And we want to find AC, so that's your hypotenuse, so I'm going to label that as C. And I'm going to do the Pythagorean theorem. So I have a 2 root 5 squared plus another 2 root 5 squared equals your hypotenuse squared. So 2 squared is 4, a root 5 squared is a 5, a 4 times a 5 is a 20. So same thing with my next one, I have a 20. And that equals c squared. So I have 40 is equal to c squared, and taking the square root of both sides, I wind up with the square root of 40, but I do need to simplify that. The largest perfect square factor of 40 is 4. I can split 40 up into a 4 times a 10. And so c comes out to be the square root of 4 is a 2. The square root of 10 cannot be done, so 2 root 10. All right, for this next problem here, we're going to use what we know about Pythagorean triples to help us out. So we won't have to do any Pythagorean theorem on this one. We have a trapezoid. In a trapezoid, we can drop down the heights on both sides, and the heights are equal to one another. So since the height here is 24, this would also be 24. And so if I look at this right triangle, that is the 10, that is a multiple of this Pythagorean triple. If I multiply all these by 2, I would get the side lengths. So the missing side length is the 5 being multiplied by 2, because I have the 12 being multiplied by 2 and the 13 being multiplied by 2 to get these two sides. So this is 5 multiplied by 2, or a 10. Now, not all trapezoids are like this, but this one happens to be like this. These two sides here are equal. So this is also a 26. So that pink triangle and the green triangle are exactly the same, meaning that this is 10 as well. Well, this side here on my trapezoid is equal to this part here. So if I do this 10 plus this, I would get x, and that little side here is 20. So x would be equivalent to a 10 plus a 20 plus a 10, which is a 40. Okay, so looking at number 11, we're also going to be using Pythagorean triples, so we don't have to do any Pythagorean theorem work on this as well. Now, for number 11, this is an example of the 5, 12, 13 Pythagorean triple, where all of the sides on this triangle are multiplied by 4. So a 5 times a 4 is a 20, 12 times a 4 is a 48, so your hypotenuse would be the 13 times a 4, which is a 52. Now on this triangle that I'm highlighting in blue, this is an example of your 7, 24, 25 Pythagorean triple with the multiple being 2. If I multiply a 7 times a 2, I get a 14. If I multiply that 25 times 2, I get a 50. So I need to multiply 24 times 2 to get the other leg of this right triangle, and that ends up becoming 48. So now I'm going to work on this triangle here. Which ends up being a multiple of the 8, 15, 17 Pythagorean triple. If I do 17 times 6, I get a 102. If I do 8 times 6, I get a 48. So I need to do 15 times 6 to get my other side length, which would be a 90. From here, I can find this little portion by taking this 52 and subtracting this 14. So 52 minus 14 gives me that this little portion is 38. So then to find x, what I would need to do is I would need to take this 90 minus that 38. So x comes out to be 52. All right, that brings us to the end of our Pythagorean theorem review, because you guys have learned the Pythagorean theorem already in algebra.